Now that we already have the formula for combinations, let us look at it in more detail. So you have NCR equal to n factorial divided by r factorial and n minus r factorial, right? So you have to remember it. So n factorial divided by n minus r factorial is same as what permutations were, and you have this r factorial factor, which is a division which has to be done for combinations. And we had proved it for r between 0 and less than equal to n. But actually we can define NC0 as 1. So for r equal to 0, we have NC0 equal to 1. Just we call it the number of ways to select 0 or no object. So there is only one way to not select any object, right? If we have, say, n objects and you don't want to select any one, then there is only one way to select nothing. So that's what this is saying. So if you look at what this is for r equal to 0, what the right hand side is, it is n factorial divided by 0 factorial, and this n minus r factorial is n factorial because r is 0, and then n factorial and n factorial cancel, and 0 factorial is also 1. So we have 1 for r equal to 0, and that means that we have proved that this formula holds now for r equal to 0 as well. So this formula is more general. So you can just apply this formula now. So let us look at some interesting properties that come out of this formula. The first property is, so I'll call them the properties. The first property is that number of combinations of n objects taken n minus r at a time, or selections of n minus r objects from n, is same as selections or combinations of r objects out of n. So now this is very interesting. So if we actually look at the formula, it will be very obvious. So for left hand side is equal to n factorial divided by n minus r factorial, and then you have to replace n minus r by n minus r, right? Just substitute n minus r instead of r in that formula, and then you will get this. And what is n factorial divided by n minus r factorial? And what is n minus r? That is r factorial, right? So this is same as NCR, right? And this is same as the right hand side. So you have proved it. So this, you proved that selections of n minus r objects, ways of selection of n minus objects is same as n objects, r objects, right? So this is the combinations. So why is that true? We can actually look at one example to see. The same example I look at was the tennis players, where you had Nadal, Federer, and Djokovic again, right? And n is equal to 3 here. You have 3 objects, and I was selecting 2 players, right? So if I select 2 players, r is equal to 2, right? And what is n minus r? So if I have to select, say, n minus r, in this case, that is equal to 1, right? Because n equal to 3 and r equal to 2. So you have 1, selecting one object. So when I was selecting two objects out of these three, then I can select in three ways, right? We had listed them before. So Nadal and Federer, Federer and Djokovic, and Djokovic and Nadal, right? So we already know this. So now the question is, whenever I select Nadal and Federer, who is the player that is left? That we'll put on the right hand column. So here Djokovic is left, right? And Federer and Djokovic, when they are selected, who is left? Nadal. Djokovic and Nadal, if both of them are selected, who is left? Federer, right? So for each of these two players who are selected, the one player who is not selected, I am putting on the right hand column. So if I had to select only one object from these three, then the selections are Djokovic, Nadal, and Federer, right? Right? So actually, whenever I select two objects, I am also getting all the selections for just one object, because there are three objects. I select two objects and one is remaining, and whatever I don't select is also like a selection for one object. So NF is selected for two objects simultaneously. D is selected as a choice for one object. So this is like same as NCR, and this is same as N choose N minus R, right? So these two are equal, that's why. So I'm just giving the intuition behind why N choose R is same as N choose N minus R, just because whenever I select these two, I automatically am actually making the selection for N minus R, or 1 here. So I hope that it gives you some intuition. The second property to cover is that if N choose A is same as N choose B, that implies that A is equal to B, or A is equal to N minus B, right? So why is that? Because obviously if A is equal to B, then both sides are equal. But the second case is when we already know that N choose A is same as N choose N minus A, right? So then this option of B equal to N minus A, or A equal to N minus B, which implies A equal to N minus B, is also there. So these two options are very clear from the previous property. So let us do a problem actually which will make this more clear. So I'll go to the next page for the problem. So the problem is, if N choose 9 is equal to N choose 8, find N choose 17. So you should be able to actually do it looking at the property 2, which I had already covered. So the answer, the choices are 16, 18, 216, and 1. The correct answer is 1. So let us look at this problem. So let us look at the solution now. So we know that NC8 is equal to NC9, and now we have to find NC17, right? So it's clear that to find NC17 we need to find N. So finding n would imply that from this equation which we have, we need to just solve for n. So what is nc8? You should keep on using the formula more frequently. It's just n factorial divided by 8 factorial divided by n minus 8 factorial, right? So just keep on applying the formula and you'll get better at it. And then nc9 is n factorial divided by 9 factorial divided by n minus 9 factorial, right? So n factorial here can cancel, and then we have 8 factorial and 9 factorial, which will leave us with 9. So this is something which we have done in factorial notation. And then we can cross multiply and see that you are left with 9 equal to n minus 8, because n minus 8 factorial will cancel with n minus 9 factorial and leave n minus 8, right? Because n minus 8 factorial is n minus 8 multiplied by, I'll write it down here, but you should have seen it in factorial notation, n minus 8 into n minus 9 factorial. This is just the application of the formula that n factorial is same as n into n minus 1 factorial. So this is standard, and we are doing it in factorial notation, and now we know that n is equal to 17, right? Now we have to find n choose 17. What is n choose 17 now? That is same as 17 choose 17, which will be same as 17 factorial divided by 17 factorial divided by 0 factorial, because you have n minus r, so it's 0 factorial, which is 1. So this is equal to 1. So this is the right answer. Okay.